Hello everybody, welcome into another lesson. So today we are going to continue in with solving systems of equations. And whenever you have a system of equations, you can always use the substitution method, but sometimes that's not the quickest, most convenient way to do it. So there is another way. Today we're going to focus on the addition and subtraction method. The addition or subtraction method. That's what we're going to focus on today. To use the addition or subtraction method, all you have to do is take these two equations, add them together. I'll show you how it works here. So you have x plus y equals 7, then x minus y equals 3. Well, you'll add the second equation to the first. If you do that, x plus x, that gives you 2x. Then you get y minus y, that's 0. Then you get 7 plus 3 equals 10. So by doing so, you can eliminate one variable. You just get 2x equals 10, which we know then x would equal 5. So we found the x-coordinate of the solution. Now we need to find the y-coordinate of the solution. So all you would have to do is take that x-coordinate, put it into one of the two original equations. So it doesn't matter, we'll go with the first one. So we'll have x plus y equals 7, so we'll put in 5 plus y equals 7, which would mean y would equal 2. So we got the x-coordinate 5, the y-coordinate 2. So therefore your answer to this is going to be the ordered pair 5, 2. That would be the solution to this system of equations, would be 5, 2. This especially works when you have one coefficient on one of the variables in one equation being positive and one of them being negative. If they're the same coefficient but one positive, one negative, like the y is a positive 1, and then in the second equation the y is a negative 1 for the coefficient. So you could add them together and you'll get your equation with a variable eliminated, and then you just go from there. But I do have more examples here. Let's see. We have a plus b equals 5. Then we have a minus b equals 7. So we are given a plus b equals 5 and then a minus b equals 7. Well, if you notice between the first equation, the b has a positive coefficient of 1, then the second equation, the b has a negative coefficient of 1. So that means we can just add the second equation to the first. Let's go ahead and do just that. So a plus a, that gives you 2a. Then b minus b, that gives you 0. 5 plus 7 equals 12. So you've eliminated the b variable temporarily. You just have 2a equals 12, which means a equals 6. So the a coordinate is going to be 6. Now, what you're going to want to do is find your b coordinate, and you're just going to take that a equals 6, stick it in one of the equations. I'll go with a plus b equals 5. So that would be 6 plus b equals 5, which means b would equal negative 1. So the a coordinate's 6, the b coordinate's negative 1, so the ordered pair for the solution is going to be 6, negative 1. That would be the ordered pair that gives you the solution, is 6, negative 1. Alright, what's next? Let's see, we have 3n minus 2t equals 16. Then we have 5n plus 2t equals 8. Well, if you see an equation like this, I think it's readily apparent why you wouldn't want to opt for the substitution method, because then you're going to have a bunch of fractions you got to deal with. I mean, you can use it if you really want to punish yourself and deal with fractions, but when looking at these systems of equations, look to see if you have the same coefficients. Basically, you do on the t variable. The first equation you have a negative 2t, the second equation you have a positive 2t. So it looks like we can eliminate the t variable by adding the second equation to the first. So let's go ahead and do that here. So 3n plus 5n, that'll give you 8n. The negative 2t plus 2t, that's 0. So 16 plus 8, that's 24. So you've eliminated the t variable temporarily. You get 8n equals 24, which means n equals 3. So the n coordinate is going to be 3. Now all we got to do is find the t coordinate. So you just pick one of your equations to stick it into, and then you solve for your t coordinate. So I'm going to put it in the second equation this time. So 5 times the n value of 3 plus 2t equals 8, which would give me 15 plus 2t equals 8. So that means 2t would equal negative 7, so t equals negative 7/2. And again, you can get fractional answers for coordinates. That is perfectly normal. So the n coordinate's 3, the t coordinate's negative 7/2, so the ordered pair for your solution will be 3, negative 7/2. That's exactly what you would get, would be 3, negative 7/2. Alright, what's next? Let's see, we have 3c plus 5d equals 17. Then we have 3c plus 8d equals 5. So here we're given 3c plus 5d equals 17, and then 3c plus 8d equals 5. Well, immediately the c coefficients in both equations should jump out at us. We have positive 3's on both. But we can subtract the second equation from the first, because after all, this is the addition or subtraction method. You can actually subtract the second equation from the first. So 3c minus 3c, that goes to 0. 5d minus 8d, that's negative 3d. Then we have 17 minus 5, that's 12. So you get negative 3d equals 12, which means d is going to equal negative 4. So we found the d coordinate to be negative 4. So now what we have to do is solve for the c coordinate by putting the value of the d coordinate into one of the equations. I'll go with the first one, the 3c plus 5d equals 17. So let's see, we'll have 3c plus 5 times negative 4 equals 17. Which means you'll have 3c minus 20 equals 17, which would give you 3c equals 37, that means C would equal 37 thirds. So the C coordinate is 37 thirds. That means you're going to, let me just check something here, minus 40. Yep, so let's see. Your C coordinate, so that's 37 thirds. And then your D coordinate's negative 4. So the ordered pair you're looking for is 37 thirds, negative 4. That would be the answer to this. Let's see, we got 12n plus 3m equals 18. Five n plus 3m equals 4. So this time we have the equations 12n plus 3m equals 18, then 5n plus 3m equals 4. Well, the m should jump out at us because both of these have positive coefficients of 3, so that means we can subtract the second equation from the first. So let's go ahead and do just that. So 12n minus 5n, that's going to be 7n. 3m minus 3m is 0. Then 18 minus 4, well, that's 14. So now you've eliminated the m variable. You get 7n equals 14, which means n equals 2. So the n coordinate for the solution is going to be 2. Now, all we have to do is stick that n value of 2 into one of these equations, and then we'll end up getting the m coordinate. So I'll stick it in the second one. So we'll take 5 times 2 plus 3m, set that equal to 4. So you would get 10 plus 3m equals 4, which means 3m would equal negative 6, which means m would equal negative 2. So the m coordinate is negative 2. And remember, we want this in alphabetical order, so your m coordinate will go first. That would be negative 2, 2. So the solution for these two equations would be negative 2, 2. Alright. Let's see. 3a minus 5b equals 31. 7a minus 5b equals 59. So we have the two equations, 3a minus 5b equals 31, and then we have 7a minus 5b equals negative 59, equals positive 59, excuse me. Well, we look at the b variable, both coefficients are negative 5. So if we subtract the second equation from the first, we can eliminate the b variable and solve for a. So 3a minus 7a, that'd be negative 4a. Negative 5b minus 5b turns into negative 5b plus 5b, which is 0. And 31 minus 59, that's going to be negative 28. So we have negative 4a equals negative 28, which means a equals 7. So the A coordinate for the solution is 7. Now we need to find the B coordinate for the solution. So what we're going to do now is stick the A variable, the A value into one of these equations and solve for B. So we'll take 3 times 7 minus 5B is equal to 31. Well, 3 times 7, that's 21, minus 5B, that would equal 31, which means negative 5B equals 10. So then B would equal negative 2. So the B coordinate's going to be negative 2. So your solution to this is the ordered pair 7, negative 2. That's exactly what you should see, is 7, negative 2. All right. (6p minus 7q equals 28). So we have 6p minus 7q equals 28. Then we have negative 6p plus 3q equals negative 12. Alright, so we have the two equations, 6p minus 7q equals 28, the negative 6p plus 3q equals negative 12. Well, on the p's, we have one coefficient of positive 6, one coefficient of negative 6. So we can add the two equations together and we can eliminate the p variable temporarily. So 6p minus 6p is 0. Negative 7q plus 3q, that's negative 4q. Then you have 28 minus 12, that's going to be 16. So we have negative 4q equals positive 16, which means q equals negative 4. So the q coordinate's going to be negative 4. Now all we got to do is solve for the p coordinate by putting that value of the q into one of these equations. So I'll take 6p minus 7 times negative 4, set that equal to 28. So then you'll have 6p plus 28 equals 28. So 6p equals 0, which means p equals 0. So the p coordinate for the solution is 0. So the ordered pair that is your solution is going to be 0, negative 4. That would be the solution we're looking for, is at 0, negative 4. So I think you're beginning to see why we don't always want to go for the substitution method. It's just not always the best one to use. Alright, let's see. 4a minus 7b equals 13. Then we have 2a minus 7b is equal to 3. So we have this system of equations here where we have 4a minus 7b equals 13, 2a minus 7b equals 3. Well, on the b variables, both coefficients in the equations are negative 7. That means if we subtract the second equation from the first, we can eliminate the b variable temporarily. So 4a minus 2a, well that's 2a. Negative 7 minus negative 7, well that turn into negative 7 plus 7, that'll give you 0. Then 13 minus 3 is 10. So now you're left with 2a equals 10, that means a equals 5. So the a coordinate for the solution is 5. Now we want to find the b coordinate for the solution. All we have to do is put the a value into one of these equations. I'm going to go with the 2a minus 7b equals 3. So you'll have 2 times 5 minus 7b equals 3, which means you would have 10 minus 7b equal to 3, which would give you negative 7b would equal negative 7, which means b equals 1. So the b coordinate for the solution is 1. So your ordered pair you should get for the solution would be 5, 1. That would be your ordered pair that gives you the solution to this system of equations would be 5, 1. Alright, about 4 more, then we're done. 2c plus 3d equals 0. Then we have 5c minus 3d equals 21. So this particular system of equations, we have 2c plus 3d equals 0. Then we have 5c minus 3d equals 21. Well, on the d variables in these equations, the first coefficient's 3, the second coefficient's negative 3. So we can add these two equations together to temporarily eliminate the d variable. So if we add these, 2c plus 5c gives you 7c, 3d minus 3d is 0, then 0 plus 21 is, well, 21. So you get 7c equals 21, which means c equals 3. So the c coordinate for the solution is 3. Now all we want to do is find the d coordinate. And we're going to put the c value into one of these equations. I'm going to go with 2c plus 3d equals 0. So you'll have 2 times 3 plus 3d equals 0. That means you'll have 6 plus 3d equals 0, which would give you 3d equals negative 6. That means d equals negative 2. So the d coordinate for the solution is negative 2. So the ordered pair you should get for your solution would be 3, negative 2. That would be the ordered pair that gives you the solution, 3, negative 2. Three more. So we have negative 3x plus 5y equals 45. Then we have 3x plus 13y equals 9. Alright, so in this particular system of equations, we have negative 3x plus 5y equals 45. Then we have 3x plus 13y equals 9. Well, if you look at your x variables, the first coefficient's negative 3, the second is positive 3. So we can add these two equations together to temporarily eliminate the x variable. So negative 3x plus 3x is 0. 5y plus 13y, that's 18y. That's going to be equal to 45 plus 9, that's 54. So you have 18y equals 54, which means y equals 3. So the y coordinate for the solution is 3. Now all you're going to have to do to find the x coordinate is put in your y value into one of these equations. I'm going to go with negative 3x plus 5 times 3 equals 45, which means I'll get negative 3x plus 15 equals 45, which would give me negative 3x equals 30. So that means x would equal negative 10. So the x coordinate for the solution is negative 10. So I would get the ordered pair negative 10, 3 as my solution to this system of equations. You'll have negative 10, 3 as a solution. Two more problems, then we're done for the day. Let's see, 12p minus 18q equals 14. Then we have negative 15p minus 18q equals negative 4. Well, so 12p minus 18q equals 14. Negative 15p minus 18q equals negative 4. If we look at the q variable, both coefficients are negative 18. So if we subtract the first equation from the second, we can eliminate the q variable temporarily. So 12p minus 15p turns into 12p plus 15p. That would give you 27p. The negative 18q minus negative 18q turns into negative 18q plus 18q, which is 0. So then you'll have 14 minus 4 turns into 14 plus 4. That would give you 18. So you'll have 27p equals 18, which means p would equal 18 over 27. Well, both 18 and 27 divide by a factor of 9. So your real value of p is going to be 2/3. So the p-value for the p-coordinate for the solution is 2/3. Now all I got to do to find the solution is put it into one of these equations to find my q value, which I will do with the first one. So I'll take 12 times 2/3 minus 18q. That'll be equal to 14. 12 times 2/3, so let's see, 4 times 2, that'd be 8. I would have 8 minus 18q would be equal to 14, which means negative 18q would equal 6. So that's going to give me a q value of 6 over negative 18, which is negative 1/3. So my q coordinate for the solution is negative 1/3. So the ordered pair I should get for my solution would be 2/3, negative 1/3. That would be the ordered pair I'd end up getting for the solution, 2/3, negative 1/3. Then there's one more problem and we're done for the day. All right. We have 9y plus 5z equals 1. Negative 9y plus 5z. Oh, I'm sorry. Negative 9y minus 10z. I was double copying. So negative 9y minus 10z equals 2. Alright, so this system of equations, we have 9y plus 5z equals 1, negative 9y minus 10z equals 2. Well, let's look at the y coefficients. The first coefficient's positive 9, second coefficient's negative 9. So we can add these two equations together and we can temporarily eliminate the y variable. So 9y minus 9y is 0, and 5z minus 10z, that's negative 5z. That's going to be equal to 1 plus 2, which is 3. So negative 5z equals 3, which means z is going to equal negative 3/5. So the z coordinate for the solution is going to be negative 3/5. So we found z, let's find the y. I'm going to put that into the 9y plus 5z equals 1 equation. So that's going to look like 9y plus 5 times negative 3/5 equals 1, which would give me 9y minus 3 equals 1, which would give me 9y equals 4, which means my y would equal 4/9. So my y coordinate for the solution is in fact 4/9. Going in alphabetical order, we'll list the y coordinate first, then the z second. So my solution for this should be the ordered pair 4/9, negative 3/5. That would be the ordered pair, that is the solution for this equation, would be 4/9 and negative 3/5. So that's it for this lesson. Next lesson, we're kind of going to continue with the addition subtraction method, but we're going to throw multiplication and division in with that, because you're going to have a system of equation where none of the coefficients are the same, and you're going to have to use multiplication and division to manipulate it to make them the same. So stay tuned for that. I hope everyone has a good day. Take care.